Hello, this is the walkthrough for the practice paper for the Year 9 exam. It's a practice for you, so you can see what sorts of things you might get asked. Obviously, you've been doing a lot of factual revision with Mrs. Jackson, but this will obviously give you an opportunity to really sort of practice questions and see how you can actually apply your knowledge to answering exam-style questions. So this particular exercise, hopefully you've had a go at it first. You've done maybe the first sort of 20 minutes of questions, doing as much as you possibly can. It's not expected that you do all of it because this would take you about 52 minutes or about 3/4 of an hour up to an hour to do from start to finish. But what we're going to do is I'm going to take you very quickly through the questions and show you how to answer them and hopefully teach you a little bit of extra chemistry alongside it. Okay? So without any further ado, we're going to start on question number 1. So with the exam papers, just to give you an idea, what usually happens is it starts off with the easy questions at the beginning and then the more involved questions appear at the end of the exam to give you a bit of confidence as you're working through it. But you should always go through the exam paper first really and just answer what you can answer straight away and then worry about the bits you can't anyway, so later on. So the first question is about balancing an equation. So it says you've got a group, so it's all about group 1, so that's where it's relevant to our area of study. It says sodium reacts with chlorine to produce sodium chloride, balance the equation. So you've got to make sure you've got the right number of atoms either side. So here at the moment you've got 1 sodium, you've got 2 under the Cl there, so you've got 2 chlorine atoms, and you've got 1 sodium and 1 chlorine. So that doesn't balance at the moment. So what you need to do is maybe think about having 2. If I put 2 there, I'd have 2 sodium and 2 chlorine. So that then matches with the chlorine, but it doesn't match with the sodium. So I need to have 2 sodium here so that I end up with 2 sodium and 2 sodium chloride, so that now that one has become a 2, 2 and 2, 2 and 2, job done. So then it says 46 grams of sodium reacts with 11.7 grams of sodium chloride. What mass of chlorine is reacted? So this is really a bit of recap from Key Stage 3 from Year 7 and 8. The mass of chlorine that's reacted, well, it's using a thing called conservation of mass. The total mass before is the same as the total mass afterwards. So if you've got, if you ended up with your product of 11.7 grams, here you've got 4.6 grams of your reactant. So I need to subtract 4.6 from there and I get 7.1 grams, and there's my answer. That's it, and I just write it in there, 7.1, job's done. So for part C, it says teacher puts hot sodium into a gas jar of chlorine. The changes seen before, during and after the reaction were observed. You have to just basically complete the sentences by choosing the answers from the box. So the first thing to say is sodium is well, we know sodium, it is a solid, but what are we thinking about as this description? Well, it's a metal, so does it say metal? No, I can't say it's a metal solid, so it's about its appearance. So sodium being a metal, it's shiny, so it's going to be a silver coloured solid, okay? The chlorine is chlorine is usually a green gas. Okay, and so when you burn the sodium in the chlorine, it burns with a yellow flame. Okay, and the sodium chloride is sodium chloride is white. It's changed colour. Okay, it's a little bit of stamp collecting, but you kind of do need to. But some of it you can work out. You can certainly work out that sodium's silver coloured because that's probably the best option here. I think the only one that might be a little bit confusing is that it says chlorine is a green gas. Some people might put yellow. It says here sodium chloride is an ionic compound. Write the formula for the ions in sodium chloride. So if we think about it, we've got sodium. So sodium is it's in group 1. So that will produce sodium positive. Chlorine's in group 7, so it forms a -1 ion. So that's chlorine with a negative. Okay? That's pretty simple. So on to the next question. complete the sentence. It says you have to answer from the box. It says potassium is more reactive than sodium. What does that mean? It means the potassium loses, well, the reason is if it's more reactive, it loses electrons. Its electrons are the particles responsible for chemical reactions. How does the size of potassium atom compare with the size of the sodium atoms? And give a reason. So the potassium atom, if we think about it, it's further down the periodic table. So one way to look at it is to take your periodic table, which is always attached to your exam papers. If we look at it, we've got, it says potassium is this one here, K, and sodium is Na. Okay, so potassium's lower down, so it's a period down, so it's got an extra shell. Which means potassium is larger than sodium. Excuse me. Now you've got to be reasonably precise here. We want to make it really clear what we're trying to say. So we could use it a whole sort of mini sentence there. The reason why it is potassium has more shells, more electron shells. Okay, so the next question is question number 2, which is traditional to come after question number 1. So it's about structure and bonding. It's used to explain the properties of compounds. Metal atoms react with non-metal atoms to form ions. Which of the elements do not form ions? It would be the noble gases, because noble gases have full outer shells, so they don't gain or lose electrons to have a full shell. The next part, potassium reacts with chlorine to produce potassium chloride. So if I've got potassium chloride there, let's have a look at what the picture shows. You've got your potassium, you've got your chlorine, and then it shows the ions, the cross and dot diagrams. It says the dots and crosses represent electrons. And I need to describe what happens when a potassium atom reacts with a chlorine atom to produce potassium chloride. Answer in terms of electrons. So the first thing to think about is what's happened here with the potassium. So the potassium has lost its electrons, okay? So the potassium has lost its outer electron. Okay, that's pretty simple. And what's happened to the chlorine? Well, chlorine has 7 electrons in its outer shell, so it's gained an outer electron. So chlorine has gained an outer electron. Okay, so I've described what's happened to the atom, but it's a 4-mark question, so I need to think very, very carefully about my answer. Well, the potassium has, I've got to be very, very careful here. Well, first thing I've got to do is think about my level of precision with my language. Well, it's not just lost outer electrons, it's lost 1 outer electron. So I'm going to change that to 1 outer electron, okay? And chlorine has gained 1 outer electron, okay? So the idea is I'm making it really, really clear. I could sort of just about get away with it by saying an outer electron, but if I say 1, I've made it really clear that I understand the chemistry behind it. And so that's I think, worth 3 marks so far. So to think about the 4th mark, what else do you want? Well, it wants the idea that it forms outer shells. To form full outer shells, I should say. With both ions. It's not asking about how it's attracted or anything like that, but that's the basic idea. It forms the full outer shells with both ions. So you'd get 1 mark for saying that potassium has lost an outer electron. get 1 mark for saying potassium's gained an electron, get 1 mark for, I think, for being a bit more precise and referring to the fact that it's just 1, because they're both, that's in group 1 in the periodic table, that's in group 7. Okay, so it can only gain 1 electron, that can only lose 1 electron. That makes sense. Okay, so moving on to part C. Part C, you've got solid ionic compounds. Oppositely charged ions attract to form a giant structure. Which structure represents the arrangement of ions in solid potassium chloride? So if we're looking in the solid potassium chloride, well, yeah, which one of these is correct? Well, if we've got negative charges here, they're not going to attract like that, they're going to repel, so that's not right. And obviously that one's got, again, 2 negative charges together, so they're not going to attract, they'd repel. Here we've got every single negative charge is attracted to a positive charge, so that's a much better lattice. So there's your answer. Non-metal atoms share electrons to form covalent bonds. The table below shows the number of electrons in the outer shells of hydrogen atoms and oxygen atoms. Okay, so it tells you in the first one, that it's that hydrogen has 1 electron in its outer shell, oxygen has 6. Okay, where's it going with this, I wonder? So the first thing it does here is it says figure 2 shows part of a cross and dot diagram for a molecule of water. Complete the cross and dot diagram, and you should only show electrons in the outer shells. So the idea is meant to be that we've got the correct number of outer shells. So hydrogen will have two electrons in its outer shell in total, because it'll have 1 from the hydrogen, 1 borrowed from the oxygen. So we'd probably want to do exactly the same there. You've got exactly the same bond there. So if I make the crosses from the oxygen atom, then I know that to have a full outer shell, it would have to have 8 in total, with 2 of them being borrowed from the oxygen. So I'm going to put in 1, so we've got 1, 2, 3, 4, 5, 6, I'll put maybe over here, 7, 8. Job done. That's it. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So that's a full outer shell for the oxygen. Hydrogen only has 1 shell, so it's only got only needs 2 electrons in its outer shell to have a full outer shell. 1, 2. So the idea is that the covalent part is where the electrons are shared in a covalent bond. So this is a simple covalent structure. Then the next question says silica, it has a giant covalent structure. You've got, it's drawn a picture of it for you there. So these little grey dots are oxygen, the larger grey dots are silicon. And it says determine the ratio of silicon to oxygen in silicon. You're really just looking at the ratio here. Well, we've got 1, 2, 3, 4, 5, 6 silica atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 oxygen atoms. So there are 12 oxygen atoms, 6 silicon atoms. So the ratio is going to be, for every 1 silicon atom, there are going to be 2 oxygen atoms. However, it would actually be accepted if you'd actually just counted them and said 6 to 12. That would have been fine. But really, with a ratio, just like in maths, you should be trying to simplify it. On to the next one. So on to the next question. So this is question F. It's all about polymers. So we need to think very, very carefully about what we're saying here. It says it shows you a picture of the 2 polymer molecules. What holds polymer molecule 1 and polymer molecule 2 together in the polymer, not what holds the atoms together. So be very careful. It's not a covalent bond. Okay? Yes, between here and here there are covalent bonds, but it wants to know about the bond between here and here. So it's not electrostatic because it's not an ionic substance. So it must be a weak intermolecular force. Right, question G. Figure 5 shows the melting point of a polymer as the length of the polymer molecule increases, and you have to describe the trend. So we're just going to be a little bit sensible here. We want to describe the trend. It's a 3-mark question. It doesn't particularly want much of an explanation because it wants a description, not an explanation. Okay? So let's start off with the obvious. We can see that as the length increases, the melting point increases. So it's worth stating the obvious. Okay. And then we just need to think about maybe just having a bit more. You can actually say, if you get 1 mark for saying that the melting point increases, 1 mark for saying that the length increases. So that's worth 2 out of your 3 marks already. So your 3rd mark is really just going to a little bit more detail. You can see that's definitely the trend here, but as you get to here, we can see it levels off. So we can say that the melting, however, the melting point levels off for larger molecules. However, the melting point levels off for larger molecules, or very large molecules. Okay, and that is how you answer that question, because it's the idea that you've got a polymer, they've got long chains. The bigger the chain, the higher the melting point to a certain extent, because it's hard, because the particles are bigger, and so it's harder to pull them apart. But it's also well worth noting that when you get to very large long chains, actually they can have very similar melting points. That's basically it. Moving on to question number 3. Question number 3 is a nice little question on periodic table. I think we have seen this one before, but let's just go over it together. So this question is about sodium and chlorine. Figure 1 shows the positions of sodium and chlorine on the periodic table. So this is sodium, this is chlorine. It wants to know one difference in the electronic structure, in other words, the arrangement of electrons of chlorine, and one difference between the chlorine and the sodium. So let's start with the idea they're on the same group, okay? So, sorry, in the same period. So they're all in the same row. So the similarity, we could say that they're in the same, well, let's use the correct term, the same period, which means, this is the important bit, the same number of electron shells. Okay, well worth being very precise about our language as we write that. Okay, and then the difference, well, sodium's in group 1, the chlorine's in group 7. So if the sodium's in group 1, the sodium only has 1 electron in its outer shell. Only has 1 electron in its outer shell. The chlorine has 7 electrons in its outer shell. Okay, so that's basically it. So we're looking for sort of different, the most obvious difference and similarity. There are more subtle things, like you can say that they both have electrons in the 3rd level. They both have incomplete outer shells, but let's just keep it simple. We have the stuff that we already know. So you're on to another 4-marker question here, which is about sodium atoms. It says sodium atoms react with chlorine atoms to form sodium chloride. Describe what happens when the sodium atom reacts with a chlorine atom, and you have to write about electron transfer in the answer. So you have to think about, first of all, what's going on here. The first thing to remember is sodium is a metal, okay, and chlorine is a non-metal, which means it's ionic. It forms ionic bonds, okay? So it says describe what happens when they do that. So the sodium loses 1 outer electron, which is gained by the chlorine atom. Okay, so what happens is the sodium forms a positive ion because it's lost an electron. And the chlorine has gained an electron, so it's formed a negative ion. In fact, it is basically what we call a chloride. Okay, so the two ions, the ions are attracted. And I would probably put in there ionic bond. Now I think I'm probably having a slight overkill on here. If I think about this as an examiner would, I'd get a mark for saying that the sodium loses an electron. I'd probably get another mark for saying it loses one. Similarly, the chlorine atom forms a negative ion because the chlorine gains one atom, one electron. So again, I think probably that first sentence might actually be enough to give me the 4 marks. But these couple of extra sentences, they're sort of an insurance, because if you read the question carefully, describe what happens when they react. Okay, so it says write about electron transfer in your answer. So it really wants to know, how many electrons are gained or lost and whether they're gained or lost. So if I move on to question number 4. So question number 4, what suggests the limitation of using a ball and stick model for a water molecule? Well, there are lots of different things that you could say. For a start, it's not 3-dimensional, okay? Well, molecules are 3-dimensional things, and that's not 3-dimensional because it's on a piece of paper. I suppose you could also say they're not to scale, okay? And also, as a result, there might not be the correct arrangement, might not be in a correct arrangement. Okay, there we are, in space. So that's basically it. You could also say that the shells aren't shown. You could talk about all sorts of things, but we're really looking for why that's not actually what the molecule actually looks like. So it then says ice has a low melting point. Water molecules are ice held together by intermolecular forces. Ice has a low melting point because the intermolecular forces are, well, they're weak. It means it takes less energy to pull them apart, so they're weak. Okay. So the next question looks harder than it is. The image shows the structure of a molecule where you've got an oxygen atom, a hydrogen atom, and a carbon atom. And it says, what's the molecular formula? You think, what on earth does that mean? Well, all you're doing is you're counting, okay? So we could count the carbon atoms, because we know we've got carbon atoms. That's the black one there. Are there any other carbon atoms? No, there's only one. We could think about the hydrogen atom. So if you've got hydrogen, you've got 1, 2, 3, 4. So I'd say H4. And last but not least, I think about the oxygen atom. There's only one of those there, so that's CH4O. That's it. That's all they wanted. Looked harder than it actually is. Okay, so diamond forms a giant covalent structure. What is the number of bonds formed by each carbon atom in a diamond? So if we think about a carbon atom, we can use our periodic table. There's carbon just there, okay? There's carbon there. We know it's in group 4, so it's got 4 electrons in its outer shell. So the number of bonds that carbon can form, it's a non-metal, so it forms covalent bonds. There are 4 gaps, so it can form up to 4 bonds, okay? Give 2 physical properties of diamond. Well, just think about what diamonds are. Well, we know that they are strong, okay, or very hard. I wouldn't say hard and strong as 1 and 2 because they're too similar, although they are slightly different. Also, diamonds have a high melting point and therefore high boiling point, obviously. Okay, and you could even say that diamonds don't conduct electricity, although I think that's a little bit sort of obvious, really. But apparently that would get you the mark. It then says name 2 other substances with giant covalent structures. Well, the obvious one would be something like graphite. Oops, try and spell it right. Graphite's an obvious one. And also, if you look back at the questions, we also saw that silicon oxide is also a giant covalent structure. So might as well mention that one, or silicon dioxide, I should say. That's right, yeah, because there's 2 oxygen atoms for every silicon atom. Because di means 2. Here we are. Okay, you can say silica, you can say silicon, you can actually say polymers, or very large polymers. You can also say fullerenes, and that carbon nanotubes, all sorts of things like that would actually get you that second one. The next question is about halogens. It says, write whether the state symbol for chlorine at room temperature, whether it's a solid, liquid, or a gas. It's something you just kind of need to know. It's a gas at room temperature. The diagram below represents 1 molecule of fluorine. Complete the dot and cross diagram on the diagram above. Well, it should be below, never mind. You should only show the electrons in the outer shells. So if we want to show cross and dot diagrams for the fluorine, we know fluorine, we can again look at our periodic table and tell straight away that fluorine has, it's in group 7, so it's got 7 electrons in its outer shell, which means that it's got 1 gap. So we need 1 electron shared from each atom, okay? And that would make 8, because you just got to add 1 more. So we need 8 electrons going around here and 8 electrons going around here. So we've got 1, 2, 3, 4, 5, 6, 7, 8. That'll do nicely. And the fluorine, again, we can say 1, 2, 3, 4, 5, 6, 7, 8. Job done. That's it. So you've got 8 electrons with nice full shells. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There we are. So that's then a fluorine molecule. Moving on, you've got a fluorine atom. It's the last question, last page of the test now, of the practice test. The fluorine atom can be represented as 19F9. Okay. And in fact, that actually does come up on your periodic table as well. Okay, there it is. So it says, it asks you what's the total number of electrons? So remember, if you've got a number, if you've got an element symbol there, and you have a number A here and a B here, that is the mass number. So that's the number of neutrons plus the number of protons. The B number is the number of protons, which is the same as the number of electrons, because the protons have got a charge of +1, electrons have got a charge of -1, so they can balance each other out. So it says we've got fluorine. It says what's the total number of electrons in a fluorine molecule? There's an F2 there, so you've got to be careful. So if you've got 2 fluorine atoms, each one's got 9 protons and therefore 9 electrons. There are 2 of them. 2 times 9 is 18. Right, part D. Aluminium reacts with bromine to form aluminium bromide. Complete the balanced equation. So we're going to increase our level of challenge here, okay? So if we think about it, we've got to be very, very careful. We've got bromine here. Bromine is here, okay? And if we look for aluminium, it's a metal, but it's in group 3, okay? So what we've got here is you've got aluminium, that's in group 3. So if aluminium can form group 3, metals lose electrons, it's got 3 electrons. If it loses all 3, you end up with a 3+ ion because you've lost 3 electrons. The bromine on the periodic table is here. It's in group 7. So group 7, you can gain only 1 extra electron to have a full outer shell. So the bromine has a charge of -1 because the ion can gain 1 electron. So we want to balance it. So how many bromine ions are we going to need to balance the aluminium? Well, if you think about it, you've got 3+, 1-. Whoops, that should be 1- there. Let's be precise. 1-. So you need 3 of those to have -3 to balance out the +3. So in other words, we would have aluminium tribromide. It'd be a 3. Okay, a little bit more complicated. You have to really think this one through. It's a really hard one to do. The second one is then to balance it. So if you've got 2 aluminium atoms here, you're going to need 2 aluminium atoms here. Okay, that's the first one. And if we think about it, if we've got 2 of these and we've got 3 bromine atoms here, and you've got 2 of them, 2 times 3 is 6. This is Br2 there. So you can actually then say that must be 3, because 3 times 2 is 6. So you have 2 aluminium atoms, 6 bromine atoms. Here you've got 2 aluminium atoms, because it's multiplied by 2. And here you've got 3 bromine atoms multiplied by 2 makes 6. So that works quite nicely. Okay? So that's another way to do it. So, when chlorine reacts with potassium bromide, chlorine displaces the bromine. It says, explain why chlorine is more reactive than bromine. So again, we've got to think about very, very carefully about how we answer this. It's a 3-mark question, but it's quite a lengthy answer. But you've got to think. So first of all, let's look for clues and ideas. You might just know this, but let's look for clues. So we've got chlorine and bromine. So chlorine is in the 3rd period, so it's got 3 shells. Bromine has 4 shells. Okay, so that might have something to do with it. Okay, so chlorine. Was it chlorine and chlorine? So chlorine has 3 shells, and the bromine has 4 shells. Okay. Now that implies that the bromine is bigger excuse me, is bigger than the chlorine atoms. Okay? So the bromine atoms are bigger than the chlorine atoms. So therefore bromine has more shielding. Okay, bromine has more shielding, chlorine has got less. So if that's the case, then so electrons are harder to remove. Oh, sorry, electrons are harder to gain for bromine. So electrons are less easily gained by bromine. I think that's what we'll say. Okay, you can say that they're more easily gained by chlorine. And that's basically it. It just wants the idea of something to do with the size or the number of energy shells. It wants to then explain what what that has to do with the price of fish. In other words, so what? So, well, we know that if bromine's got more shells, then it therefore has more shielding from the nucleus, which therefore means the electrons are less easily gained by the bromine. And that's basically it. That's more or less it. So that's the walkthrough for you. Okay, I hope it's useful. Do watch it again. Do go through your answers. Make sure you've done your corrections. Make sure you understand why. That's the important bit, is understanding why. And I hope this has been useful to you.